The last topic that we didn't get to in section 7.1 in the last class was on shifting the index of a power series. So when we take derivatives of a power series, we shift the index up by 1 when the power of x goes down by 1. If we want to use these solutions when solving differential equations, we're going to need to be able to combine terms that all have x to the n power. So we need a way to shift x to the n minus 1 and x to the n minus 2 back to just x to the n. And when we start multiplying them by other powers of x outside the series, then we're also going to need to know how to shift from maybe x to the n plus 1 back down to the x to the n. So we need a guide on shifting the index. So what we see here is that when we have a power series that starts at n naught to infinity of b sub n times x minus x naught to the n minus k, we can then take this power of n minus k and drop it to n, or bring it back up to n, as it were, by adding k to the power. But if we add k to the power, we also need to add k to the subscript of b. But much like when we were balancing algebraic expressions, it means that we need to balance it by taking a k away from the index. Let's look at a couple of examples. So in A, if we notice, we have a superscript of n minus 2 on the x term, and we have a lower limit for our summation of 2. So this one's probably going to work out pretty conveniently for us, because what we need to do is add a 2 anywhere we have an n on the inside so that we can take 2 away on the outside. So we end up with a sum from n equals 0 to infinity, and anywhere we have an n, we add 2, n plus 2, n plus 2 minus 1, a sub n plus 2, x minus x naught to the n plus 2 minus 2. So now that we can simplify this one as a sum from n equals 0 to infinity of n plus 2 times n plus 1, a sub n plus 2 times x minus x naught to the n. And we're going to find out when we get into plugging in derivatives and the power series itself into our differential equations, we will find out that this is really the form that we're looking for, because we have our x term with just an n power. What does it look like for the second one when I've got n is going from k to infinity of n times n minus 1 all the way out to n minus k plus 1, a sub n x minus x naught to the n minus k? Well, I want n minus k to have a k added to it. So the way I'm going to think about this one is, if I want to add a k anywhere I have an n, I'm going to have to add it everywhere there's an n on the inside. And if I add it on the inside, I have to subtract it on the index. So what we really end up with is the sum from n equals k minus k to infinity times n plus k times n plus k minus 1 times all the way to n plus k minus k plus 1, a sub n plus k times x minus x naught to the n plus k minus k. And when we simplify all that down, we find out that we have a sum from n equals 0 to infinity of n plus k times n plus k minus 1 times all the way out to n plus 1, a sub n plus k times x minus x naught to the n.